Hey, good afternoon. My name is Wells, and I am a computer science PhD student.
I'm Danielle, and I'm from the Applied Math Department.
My name's Kevin, and I'm in the Neuroscience and Cognitive Science program.
And so today we're presenting on Git, which is one of several tools for reproducible science.
Thank you. So the first question you may ask is, why do we even care about reproducible science, or why is this important? So it allows others and yourself to rerun experiments or codes to verify that you get the same results. So if others are rerunning your experiment, it could allow them to get better understanding, as well as maybe even expand upon your research. And for yourself, imagine that you're running code, the same code multiple times, and each time you get a different result. How do you know which one, if any, is correct? So it will help establish confidence in your own personal experiments. Not necessarily saying that what you're doing is correct, but at least you're getting the same thing each time you run your code. And so there's different tools that can help you with reproducibility. One is SnakeMate, which is a Python-based workflow management system. It basically uses some sets of rules in order to create output files that can be used for reproducibility. And one cool thing is that it just uses a single command in order to reproduce your entire pipeline of code. But what we're going to be talking about today are version control systems. So what is version control? Version control is a system that records changes to a file or a set of files so that you can access specific versions later. So for example, you're editing some code and you want to revert back to a version. I can see it down there. You want to revert back to a version of the code that maybe you had 3 days ago to do some sort of experimentation. Version control systems can easily allow you to do so. It also allows you to back up your code in case something goes missing or something happens. So it's a very important component for reproducible science because it's a way for you to reproduce your results. So you can make changes to your code or files without messing up your working code. And you can publish it so that others can reproduce your results. And it also allows for collaborative development, which is very important. So you're able to know who made changes, when these changes occur, and the differences between your code and the code that they shared with you. And that's a lot easier than using something like Dropbox, where if two people are working on the same thing at the same time, you guys may end up overwriting each other's work, which could be very bad. So you can have your own version and experiment with that, and then share whatever part that you want to with your collaborators. So some version control systems include Subversion, or more commonly known as SVN, which was published back in 2004. There's Mercurial, which was published back in 2005, and then there's Git, which is what we're going to be talking about today. So what is Git? So Git was also published back in 2005. It's a free and open source distributed version control system designed for speed and efficiency. So very fast and efficient in the storage that you use. So it has all those great features of version control systems mentioned previously, and it easily allows for disposable experimentation. So you can branch off, or we're going to get into more terminology later, but you can branch off from your existing files, kind of do some experiments, merge it with the working code that you have if you want, or kind of just throw it away if it doesn't work. So you can change your code without interfering with what your collaborators can see. So Git is a version control system which is installed on your local machine. Then there are these Git services, which are central sources that act like this cloud, so that you can push your versions of the file to this, and your collaborators can retrieve them, and vice versa. So some Git services include GitHub, which is what we're going to be using today, Bitbucket, and GitLab, just to name a few. So now we're going to get into more of the terminology and the commands for Git.
So the fundamental concept in Git is that of a repository. And so if you think about your project, it usually contains some combination of files in a couple of directories. And so the purpose of version control is basically to track the changes that are happening to this file across time. And so we have up here kind of the repository. And within that repository, you can have different stages or different commits and different snapshots. So if you kind of look at these little green dots, like you can think of each of those as being a different snapshot of your project. And so you should be able to go, you'll be able to go back to any of these different snapshots. And so in addition to, and so you can only look at one snapshot at a time on your machine, but we'll talk about the process of looking at these different snapshots. And so you're also going to have metadata associated. And so first you have this .git file. You have a little dot before the file name. That just means it's hidden. So it's not going to be immediately obvious to you. But this Git file is kind of the most important part about Git. If you don't have it, it's not a Git repo. And the second thing is you have these .git ignore files. And so this is a way for you to tell Git to ignore certain files. So we'll talk about best practices later. But one of them is to not include all of your data. And so you can have, like, in your git ignore, you can have star.pdf, star.tsv, all of these files you don't want to get to track. It will just ignore and not talk to you about them. And so where does a repository live? So you can either have a remote repository, and this could be on something like GitHub or Bitbucket, or you could have a local repository. This can be on something like your computer. So it's important to realize that these repositories are separate, and you can actually have multiple remote repositories and multiple local repositories, and that they're not kind of automatically synced up. You have to specifically tell it when you want them to sync up. And so kind of how do changes work? So the first thing is you'll make a change. Generally, you'll want to make changes to your local machine. So you can think about, you'll make some changes, and then you'll commit them, and we'll show you guys how to do this later. But you can see that now that you've made this change, so you're kind of at step 2 in your local machine, the remote doesn't know about it because you haven't told it about it. So what you have to do is you have to push it up. And so when you push your change, you're pushing it from the local to the remote, and now the remote gets updated. And so today we're going to walk through 2 example use cases that hopefully will cover the kinds of situations in which you'd want to use Git. So the first example is, let's say that you've got a code base locally and you'd like to add Git to it. Perhaps you want another collaborator, or you just want to be able to know where your changes are, like keep track of different versions of your code so it can be more reproducible. And the second one is going to be, let's say that you're joining a lab, or let's say that you've got a collaborator and they have a code base that they want you to make a minor change to. We'll work through how to work on that.
Okay. Let's now go to the use case 1. Briefly, in this part, we will introduce to you how to track the changes of your files locally and how to push it to the GitHub. Imagine a situation where you make many changes to a very complex function, and later on you suddenly realize that those changes are actually not necessary, and you want to go back. And you don't want to go through all the complex change process again, reverse the change. And so here, the Git will help you. And you will also meet some situation where ask you to publish your code together with your paper, right? They want to make sure that your results is reproducible, that everyone can download from somewhere, in this case, GitHub. So GitHub here will help you to publish your code and share it with your collaborators. So let's go to details. How to turn your local folder to a Git repository. You have to, first of all, cd to your project folder. At the same time, Wells will show you how it's going to happen here. So here we have a local folder called local codebase. Now we are going to turn this folder into a Git repository. The command we use is git init. Yeah. Okay. So git init out just allow you to initialize everything repository into a Git repository. So afterwards, you want to check the status of your, before that, you want to check the status, type in Git status. Files that in this case, there's only one file under this folder, process.py is right. Add the file, you type git add the file to the stage where file status is just outputs show you change one more step to go. Add git and just allow you to add a message about what change you have made to the file. Add git status. Now, this is an example of how you keep track of your file. Afterwards, along this project, you want to continuously add files and also make modifications on the files. And you basically form a loop of that. And along this, you want also every now and then check the status of files and git status. The command, the inspector will help you do that. So, yeah. So the second part will be how, after your project is done, you want to push your local repository to GitHub. And here's what you do. Create a remote repository in GitHub, and then copy the URL to the local computer. And then on the terminal, you type git remote add origin plus the URL. And then so now the git remote -v will allow you to see what Git repository. So the final step will be git push. Git push, it just allow you to push everything under the local repository into GitHub. So now you've learned how the process of bottom up from keeping track of your files locally to keeping track of your file remotely. Now let's invite Wells to talk about the bottom up, how to clone a project from the GitHub and collaborate with your collaborators. Okay.
So previously we looked at how you could add version control to an existing project. Now let's look at how you can use version control to work with a collaborator on an existing code base. So the main command is called git clone. And so this is basically, you want to create an identical copy of the remote repository locally. So what we can see here, if you go up, go to the other one. Yeah, so if you see here, whenever there's an existing or public Git repo, you can do git clone, and you can get the URL from the GitHub website. And so then you want to clone it down. And so it's just git clone the URL. Optionally, you can specify the name of the directory. If you don't specify the name of the directory, it will just default be the name of the repository. And so now that we've kind of shown you the basics of Git, now let's work through a more realistic workflow. So if you're just going to stick around and master the whole time, that's not all that interesting. And so really what you're going to want to do is you're going to create a branch. And so the purpose of branching is to separate your kind of stable code from your code that's in progress. Another example of this could be, let's say you want to work on multiple independent features, you want to kind of switch between, but you don't necessarily think they'll be ready at the same time. And so you can create separate branches for that. And so branching essentially lets you have multiple versions of your code, but only one version is checked out at a specific time. And so you can kind of see over here that you can kind of have master and development be at slightly different times. And so, and so in this case, we want to check out the, yes. So first, let's look at some of the commands for branching. So the first command is git branch. And so what this command does is it shows you all the branches that are in your local repository. So you can see here that there's only one. It's called master, and master is the default name for a branch in Git. And so the idea of the workflow is you want to keep master pretty clean. So what generally people talk about is they won't say that master should always run. So master should always be working code. So if you're experimenting, because I mean this comes back to the idea of production code, or in our cases, let's say our advisor says we need to run some analysis with this slightly different data set, there should always be a version of your code that works. And so in order to have a version of your code that works and still do things, we need to do branching. And so the first step is to create a new branch. And so you use that using the git branch, new branch command. So in this case, we're creating a branch called development. So if we type git branch again, you should see master and development. But we're still on master. So we need to make sure to now go use the git checkout command. And so what this does is this will check out an already created branch. Okay. And so now what we want to do is we want to kind of walk you through this example. So what we're going to do is we're going to create a new file. And we're gonna commit it to the development branch, and then we're gonna walk you through two different ways to merge your code from the development branch into the master branch. So in this case, we just created a new file, and so you can see that in addition to the README that was already there in the project, we now have a process.py file. And so we're gonna do a similar thing where we type in git status, and now we're gonna type in git add so that we can add the file. And now we're going to commit that file using a commit message. So now if we do ls, we do git stat. Yeah, so we do ls or git status, we can see that we've got these files in there and that we've got nothing to commit. So now if we go and check out the master branch, ls, you'll see that the process.py file has disappeared. It's no longer there, and it's no longer there because we have this repository that's keeping track of the changes, and we know that this process file only belongs on development and not on the master branch. And so now if we go and check out development again, if you want to do that, Peng, ls, the process.py file shows up again. And so this isn't only for files that you just created. This could also be for files that are slightly different. So when you check out each branch, you'll have the version of the file that belongs on that branch. You don't have to do anything, which I've always found, when I first discovered that, I kind of thought it was magic. So now if we want to check back out the master branch, we'll walk you through one of the ways to merge in. And so this is git merge. And so basically what this does is this just takes it takes the snapshot on the development branch and it merges it into master. Generally you can do that even if you've made changes to master in between, but sometimes you can't do that and then you have to go through a little bit more of a messy way. So we're gonna ignore that for right now. So if we do git merge development, now you can see we're on the master branch, but we've got that process.py file. So generally, your collaborators won't like you very much if you just merge everything locally, because you don't give them, like, they can't see your changes before you merge them in. And as good of a coder as you may think you are, you'll certainly make errors, and then you kind of mess up the development branch. So the kind of accepted approach is to create a remote version of your branch, and then create a pull request. So we'll walk you through how to do that. So the first thing we'll do is we're going to push, do a push again, but in this case, instead of master, we're going to specify development. So, in this case, it's important to have made sure that you've given your collaborators access. Peng, did you accept? You need to accept the invite to. So GitHub has a number of permissions. You did?
Yeah.
Perfect. And so basically so as an example, just to talk about why that failed, is I have a public repository that I created and I shared it with Peng. And so just because it's public, it means anyone can clone it down, but you can't actually contribute changes back in. You have to be explicitly given permission to do that. So one thing you can do in this case, so this is pretty common with like open source projects, where they want everyone to be able to see the code, but they don't want people to just randomly be able to make changes. So this is actually, if you ever heard of forking, you fork it, which means you create a new version of the remote repository that's yours, and then you can merge between those, so you don't have access to change the code. But now, so we've pushed this up, so if we go to the GitHub website, you can see, this is really nice, you can see that it's already telling you, hey, you just pushed a branch, you probably want to create a pull request, right? So you just say, yeah, great, thanks GitHub. You create the pull request. If you go down here, just create it. So you can see that you can view the URL. You can assign someone to do it for you. They'll get a notification, and then they'll go in and merge the pull request. So this is a great way of kind of making sure that that someone else is on board with your changes. It's also a great way to not be culpable when they say, hey, you broke it. You can be like, hey, you accepted my pull request. You were supposed to review it. Okay. Sorry, so we had someone got sick at the last minute, so I am taking over him. My throat's a little sore. Okay, so what are the best practices? So the first best practice is to commit early and often. And so you want to, it's kind of hard because it's striking the right balance between committing often, but not just doing added one line of code. So the way that I've always done it is you kind of work in increments, and once you get one increment of your code to work, you commit that part of it, and you do something like git commit, added, part X of feature Y. And so you'll sometimes see very vague commit messages, and those are very annoying when you have to go and try to figure out, oh, this used to be working, why isn't it working? And so you also don't want to commit files with metadata, and you don't want to commit data in general. So you might think, oh, I'll just add my PDF to this. But if you've ever looked at what a PDF actually is, like the behind the scenes data, it's extremely ugly. And so it's challenging. You don't want to do that. But you do want to commit all of your text files. So you can have like a README. Markdown's a great format for this. So you have a README, which explains how to do things. You'll have your different codes, and then you can have your different shell scripts and stuff. So basically this is, you want to commit your working code, and then Git gives you the options to go back and retroactively change your commits. Don't do that. You can just, there are better ways to do that. Just make your changes. Like instead of undoing a commit, just undo the change and then recommit it. So that way people kind of understand what's going on, especially if you've already pushed it locally. And then I would suggest to push when you have an actual feature that you want someone to review. But pushing is also a good idea because it's a good way of backing up your code. So whenever you push, it will be up. And that way if your computer breaks or anything, you'll be fine.
Up. Layout, let's just say, hey, I want to create a repository, new repository. So I am going to open up the terminal just to create a file, and you can do that. All right, so I just threw 2 files in there, and now you can actually see that they appear here. If we look at the history, there really hasn't been any history. Here are the changes. Added random files. And I'm just going to go ahead and commit that to
So
Matt.
don't use that commit message.
Yeah.
What he just said,
For demonstration.
please, for the love of God, do not use commit message like that. So good job of showing us what not to do, Kevin. Much appreciated.
Brevity. Let's look at the history. Oh, look, hey, they're committed. Now let's just say I want to create a new branch. Here we go. Nice and simple. On that branch now, let's say I just want to go back to default. Now I'm on the master. And the reason I actually like these GUIs a lot is because it'll show you here on the right changes that have been made. So, things that were deleted would be highlighted in red, things that were added would be in green. So it's very easy to sort of track the changes. And that's kind of why I don't like using the terminal, because it ends up just looking like a bunch of text. And I'm a pretty visual person, so I prefer to use these GUIs. And then, you have the options of just clicking a button and publishing it, pushing it to your remote repository. You can also pull stuff down. So I prefer this type of workflow. I guess with the last part of this tutorial, we can try maybe just doing some simple steps. If you want to go ahead and try pulling something from this repository.